Welcome to CCL's Training Tonight, a weekly webinar program of Citizens Climate Lobby that provides CCL supporters with access to in-depth learning opportunities on topics related to climate change and effective climate advocacy. I'm your host, Todd Elvins, and tonight's topic is weather attribution science and what we know about Hurricane Helene. Tonight, we're going to hear from CCL's research team, Rick Knight and Dana Nuccitelli, and they're going to teach us about attribution science, the process of quantifying the contribution of global warming to extreme weather and other events. And a discussion around how we can employ attribution science to Hurricane Helene, the process for how connecting climate change with extreme weather events is done, what it has found, as well as how we as CCL volunteers can employ effective communication in using its research and findings. Our speakers tonight are Dana Nuccitelli and Rick Knight. They are CCL's research coordinators. Dana is an environmental scientist and climate journalist with a master's degree in physics, and Rick's background is chemical engineering. He spent 41 years working on energy research, has been a CCL volunteer in Chicago since 2012, and joined the CCL staff in 2018. Next slide. If we've done our job well tonight, at the end, you'll be able to answer 3 questions. 1, what is weather attribution science and how is it done? And 2, you'll be able to say, how did climate change impact extreme weather events in 2024? And number 3, you'll be able to answer, what should we do about it? And with that, I'm going to turn it over to Rick. Go ahead, Rick.
Okay, thanks, Todd. You can hear me okay?
Loud and clear.
Okay, great. So first of all, what are we talking about when we use the term extreme weather? Well, here are some things that constitute weather as we understand it. Heat and drought, cold, precipitation, whether that's rain or snow or wind. Those things constitute weather, and they're connected in complex ways. So for example, heat in the ocean tends to send energy into a tropical storm, which can turn into a hurricane. And we know all about that this year. If it makes landfall, the terrible destruction it can wreak through wind and precipitation. And there are also secondary effects that we associate with weather, like flooding after a big storm, or wildfires, which are made more likely by heat and drought, and exacerbated by wind as well. And so, but the question, and wildfires, and the question for now is, how is global warming connected with what happens and the severity of these events? So that's what we're going to look at. So what the heck is attribution science anyway? A 2010 paper defined it as the process of evaluating the relative contributions of multiple causal factors to a change or event with an assignment of statistical confidence. Yikes. Let's talk like a human here a little bit. So let's focus on the key words that I've bolded. So, an individual event. For an individual event, there are multiple causal factors like the solar cycle, the El Nino, La Nina phenomenon in the oceans that moves heat around. There are other oscillations in the ocean, the Pacific Decadal, the Arctic Oscillation. These things all affect weather. Volcanoes can influence climate and weather. Wildfires mostly affect local weather. Land use changes. Air pollution can also affect weather in some extreme circumstances. And of course, global warming, which is always one of those multiple causal factors. Scientists must demonstrate that if they're going to attribute a weather event to some influence of global warming, it's not opinion. It's the outcome of rigorous analysis backed by both science and data. So that's where you get the statistical confidence that you can come to through those processes. In even plainer language, weather events are born from many factors, of which global warming is one. So, did it make the event more likely? Did it make it more severe? And if so, how much? This is how we do attribution. Now, how is it done? The two major elements of how to conduct attribution science are observation of extreme weather events in the past, using historical data as much as possible, and then simulation using computer programs that are based on established scientific laws to calculate all of the interactions and feedbacks linking the past, present, and future. The key things that fall under observation are changes in frequency of events and changes in their characteristics, such as temperature, rainfall, duration, and so on. Simulations are different. Instead of tabulating observed data, they seek to predict outcomes based on the underlying physics and chemistry. And they simulate the interconnections between these things through supercomputer modeling. So these methods must complement and strengthen each other. And neither one is sufficient by itself. So what else can we say? Observation tends to generate two specific metrics. One of them is risk ratio, which is sometimes called probability ratio. That's the ratio of the probability of passing some threshold in the presence of global warming compared to the risk if it had not been the case, if global warming had not occurred. Okay, so you might say global warming increased the risk of a certain drought, a certain severity by, say, 20%. Now, the other method is called fraction of attributable risk, or FAR. That's a way to express what is the percent chance that an event will exceed some threshold. So you might say there's a 20% likelihood that this drought would not have occurred without global warming. These things may sound similar, but they're mathematically different and have different strengths and weaknesses. It turns out that risk ratio has a much wider application, but it lacks the causation framing that you get from this FAR. So one more distinction I want to talk about. There's two kinds of attribution, unconditional and conditional. Okay, how are these different? These methods, these words refer to the type of modeling that's used. So in an unconditional analysis, all of the climate-related numbers like air temperature, ocean temperature, wind speed, and so on are calculated by the model based on some initial conditions. So let's say you start with the baseline actual global conditions on some chosen date, like January 1, 1950. And then you run the computer model to see what it tells you to expect for Atlantic hurricanes over all the years up to 2024. So you run it with and without the greenhouse gas buildup, and then you compare that with what has actually happened. So in conditional modeling, on the other hand, you would fix certain key parameters like sea surface temperature at the birth of an incipient hurricane, for example, so that you can run the model with and without the anomalies created by global warming along the storm's path, and then see what the results are for the storm's size and intensity. So both of these are used in attribution studies to answer different questions. Another question to consider is, who does this? So there are many groups that take part in these attribution studies. Three prominent ones are the American Meteorological Society, or the AMS. They publish attribution studies in their Bulletin of the AMS or BAMS. They publish a special report on this topic each December for the prior calendar year. Second, there's a collaboration called the World Weather Attribution Project, which is coordinated by Climate Central. Some of you may be familiar with them. Their partners include an institute at Oxford, the Royal Netherlands Meteorological Institute, the University of Melbourne, and the Red Cross, Red Crescent Climate Center. So lots of people from around the world. And in the third instance, attribution work is pulled together by the National Academy of Sciences and published by the National Academies Press. And Dana's going to talk about some recent reports after I talk about just one more thing. How can CCL use this knowledge, both now and in the future? A lot depends on the audience. It could be in a lobby meeting or in a presentation or at a tabling event. But regardless, there are some important do's and don'ts. 2 points are made clearly in a book from the National Academies. It says that the notion that an event may not have been affected by climate change can be difficult to justify in a climate system in which everything is connected. In any extreme event, multiple contributing factors are involved, both human-induced and natural. So let me focus on the first sentence. In any extreme event, I should say, this is also in that report, multiple contributing factors are involved. So focusing on the opening sentence, one way of kind of synopsizing it, every weather event, extreme or not, is affected in some way by climate change. And as long as we keep emitting greenhouse gases, that contribution from global warming is going to keep going up. Now, if you focus on the second sentence, another way of putting that, no weather event ever has a single cause. There are always multiple factors, and one of them is global warming. Natural factors average out over time, but global warming is different. As long as it keeps going up, so will its contribution to extreme weather. And I talk about these things because you'll encounter objections, you'll encounter statements like, the climate has always been changing, or you guys are trying to blame everything on global warming. So it's important to understand that it's always going to be there until we make it stop. And it's going to keep going up, and it's going to influence every weather event. You may not be able to say something was caused by global warming, or you could blame it on global warming, but it will always have been influenced by global warming. So with that, I think that's all I have. Oh, sorry, one last thing. So my advice would be to emphasize science over statistics, because there's underlying science that is important to be able to express. And familiarizing yourself with the underlying science is an important way to make this effective in your communications. So what I mean is that before citing probability statistics, it's better to say something about the scientific basis for the connection between global warming and an event. For example, when talking about a heavy downpour, remind your audience that global warming puts more water vapor into the air. And when talking about drought, higher temperatures drive moisture from the soil. Warmer oceans feed energy into hurricanes. Long hot spells dry out vegetation, making it more combustible for wildfires. So this way you don't talk about math, you don't talk about statistics, you just talk about common sense understanding of science. And get to know some benchmark examples of attribution for various event types: heat waves, downpours, droughts, cyclones, and so on. So to help you address questions about similar events, even if they've not yet been thoroughly studied and peer-reviewed and published. Many of these can be found on Climate Central's World Weather Attribution page. And Dana's going to talk about about a whole lot of recent examples in a minute. So, and one last thing, if asked, did an event was an event if affected by climate change? Don't say no. As many scientists do, they say, well, we don't have the data, so I have to say no. But what they mean is we don't know yet. So that's my pitch on the foundations of attribution science. So I think now, yep, I'll pass it over to Dana, and I've stopped sharing here.
Great. Thanks, Rick. And as you guys have questions that pop into your head, use the Q&A button at the bottom, and we'll have plenty of time to answer questions at the end. So I'm going to talk about the attribution studies that have been done on specific extreme weather events in 2024. I wrote a whole article on this. You can see the headline here. Todd can pop a link into the chat to go to that article from Yale Climate Connections, but we're going to go through them one at a time here. And the main types of extreme weather, Rick kind of covered this, but we're going to talk about hurricanes, heat, drought, and wildfires, which those three are pretty interconnected. And then we'll talk about floods, which are kind of connected to hurricanes, but there are also floods that are just happen due to extreme precipitation events not connected to hurricanes. So since it's hurricane season, we just got Hurricanes Helene and Milton. We're going to start there. So what happens with global warming and climate change is that we put the greenhouse gases into the atmosphere, they trap heat, they warm the air, and they also warm the oceans. And heat in the ocean, that's just energy. So as a hurricane or a tropical storm kind of goes across the ocean, the hotter it is, the more energy goes into that hurricane and the more intense the hurricane becomes. And you get basically warmer water acts as hurricane fuel. Another thing that happens is that as these hurricanes are going across warmer waters, or these storms are going across warmer waters, they intensify more rapidly. So you get a weak tropical storm that develops into a category 1, 2, 3, 4, 5 hurricane more quickly than it would otherwise have. And the good news is that we have really good hurricane forecasts that, for example, Hurricanes Helene and Milton, their evolution and their paths and everything were predicted very, very accurately. And so we had warning ahead of time telling people like you're in the path of a really, really dangerous hurricane, get out of there. But, if people aren't paying attention to the hurricane forecasts or they don't trust it or whatever reason, then a rapidly intensifying hurricane can be really, really dangerous and catch people off guard. And so it's definitely important, especially in this world of rapidly intensifying hurricanes, to pay attention to those forecasts. Another thing that happens, and we'll talk more about this when we get to the storms, but as Rick mentioned, a warmer atmosphere holds more water vapor. And so there's more water available in the atmosphere that gets gathered up by the hurricane. And so you get more precipitation than would otherwise fall. So you get more rainfall, and then you get more flooding resulting from the hurricane. And we also have higher sea levels because we have ice melting from land going into the ocean. We have warmer ocean waters expanding, so sea levels are rising. And as a result, when you get the hurricane pulling that water from the ocean up to the land, well, it's now starting from a higher point, and so you get bigger storm surges, and so you get more flooding further inland than you would in the absence of global warming. There was also just a really interesting study published that was looking at the long-term mortality in areas that have been impacted by big hurricanes. Because mortality attribution is really difficult because, it's hard to pin a person's death on an exact event sometimes. Like if there is a direct mortality associated from the hurricane itself, that gets counted. But if down the line somebody dies or prematurely because of some indirect effect of the hurricane. For example, in the recovery efforts, we spend a lot of money, put a lot of resources into the recovery, and there's less money to spend on things down the line. Or there's potentially waterborne diseases associated with contaminated water and things like that. Those deaths are not necessarily counted and attributed to the hurricane. And so this study basically looked at long-term mortality data and found that in areas hit by large hurricanes over a period of 10 to 15 years, it's generally in the many thousands of deaths that are increased, an increase of many thousands deaths. They said like something like 7,000 to 10,000 extra deaths in areas hit by big hurricanes. And so these are very dangerous, deadly, and long-term damaging events. So we had a few rapid attribution studies of Hurricane Helene and then also of Hurricane Milton. This chart on the right is from Lawrence Berkeley National Labs, doing a rapid attribution of the precipitation from Hurricane Helene. You can see the darkest green is areas that got more than 50% more precipitation than they would in the absence of global warming from Hurricane Helene. So kind of areas in like Georgia and North Carolina especially got a whole lot of extra precipitation. But in that general impacted area, in the Helene path, rainfall increased by about 10 to 50% more than it would otherwise have been because of global warming, because of that increase in water vapor in the atmosphere. And then we also learned that, of course, because we have higher sea levels, as I mentioned, we got a bigger storm surge. And so those two factors, the increased rainfall and the bigger storm surges, resulted in bigger flooding, although they didn't quantify how much, but they just said we got more flooding than we would otherwise have. And because of the higher temperatures in the ocean, the larger wind speeds resulted because there was more energy in the hurricanes. So both Helene and Milton got about a 10% increase in wind speed, 10% faster winds than they would otherwise have without global warming. But that's, it sounds 10% doesn't sound like so much, but larger wind speeds make a really big difference in destructiveness. About a 5% increase in wind speed is like a 50% increase in hurricane destructiveness. So basically, it was about twice as destructive, these two hurricanes, than they would otherwise have been. And as an example, Hurricane Milton, when it made landfall, was a Category 3. And the World Weather Attribution study said that it would have been a Category 2 hurricane at landfall if not for global warming. And so a Category 3 hurricane is considerably more damaging than a Category 2 hurricane. And then World Weather Attribution also looked at kind of we call it the return time, the frequency of this kind of intense Helene level hurricane in the vicinity of where it made landfall. And so basically it said before global warming happened, this kind of intense hurricane in this area would have been a 1 in 130-year event. Now it's about a 1 in 50-year event. So it's going to happen considerably more frequently in this particular area as a result of global warming making this type of hurricane more intense. And it was the high sea temperatures in the Gulf of Mexico that fueled these storms. And in both cases, hurricanes Helene and Milton, they said roughly the particularly high ocean temperatures that were happening at the time were made 200 to 500 times more likely because of global warming. So basically, the oceans would not have been that hot without global warming, which means the hurricanes would not have been as powerful or have intensified as rapidly without global warming. So let's switch over to extreme heat and heat waves. And so I kind of like this chart here where the yellow is kind of our previous climate. This is our sort of temperature distribution where sometimes it's particularly cold, sometimes it's particularly hot. Most of the time it's in the middle. But as you get global warming, this distribution shifts over. And so the averages are warmer, but also the extremes are hotter. So you get more what used to be extreme weather, and now you also get more what is now record hot weather because it just didn't used to get that far over on the distribution, didn't used to get that hot. So extreme heat is kind of the most direct consequence of global warming because as we increase greenhouse gases in the atmosphere, increase the greenhouse effect, that traps heat, that causes temperatures to go up. So that's like a direct impact. Heat is thought to be the deadliest type of extreme weather in the United States. Again, the attribution is tricky because, for example, if you have a heat wave and somebody gets heat stress and dies of a heart attack, then the death certificate is going to say he died of a heart attack, and it's not going to say he died because extreme heat triggered his heart attack. And so, attributing deaths to extreme weather is always a tricky thing, and it always gets undercounted. But we think that heat waves cause a lot of premature deaths. 2023 globally was the hottest year on record by far. 2024 is going to break that record again by a considerable amount. So we're in the midst of a lot of heat. In fact, July 22nd of this year was Earth's hottest day on record. And that day, according to Climate Central's analysis, about half of the people in the world experienced dangerous heat, made 3 times more likely by global warming. So, you're talking about close to 4 billion people experiencing extreme heat on that day because of global warming. That's kind of a crazy statistic. And this Northern Hemisphere summer, we had 2 billion people between June and August experiencing 30 or more days of dangerous heat. Again, made 3 times more likely by global warming, according to Climate Central's analysis. And we had a specific extreme heat event in kind of the Mediterranean region around the Mediterranean Sea, including in France, where Paris was holding the Olympics at the time. So you guys might recall during the Olympics, there was a lot of complaints about how hot it was from the athletes. World Weather Attribution did an analysis of that extreme heat event in the Mediterranean region and said it would have been virtually impossible to be that hot without climate change. However, now this is like a once per decade event in this region. So like would have used to never happen, and now it's going to happen about once per decade. So quite a lot hotter and more frequent. One consequence of this is that the Paris Olympics was really trying to be like ecologically conscious, and they tried to make these like energy efficient housing for the athletes. And then the athletes were like, it is too hot. We need air conditioners. And they had to retrofit the Olympic housing with 2,500 air conditioners and use a bunch of energy and made it less eco-friendly, which kind of sucks. But, the athletes had to be safe. And that is a consequence of global warming. We get more heat. We're going to get more people needing air conditioning, and fortunately, as developing countries have more people coming out of poverty and can afford air conditioners, we're going to get more air conditioning distributed as a result, which is good for people's safety. It's also not so good for energy use and greenhouse gas emissions, but people have to be safe, so we're going to have to deal with that. A few other examples of extreme heat this year. We had a heat wave in Mexico in the summer, which caused thousands of cases of heat stroke. World Weather Attribution looked at that one, said it was about 1.5 degrees Celsius or about 2.7 degrees Fahrenheit hotter than it would otherwise have been because of global warming. And that particular intensity of heat wave is 35 to 200 times more likely to occur in today's world than it was before human-caused climate change. The Philippines had a really bad heat wave that World Weather Attribution said would have been impossible to happen without global warming. It was like way on the extreme end. So it's an extreme event even for a world with global warming, and a world without global warming, it just couldn't have happened. There was a heat wave kind of extended into West Asia. Like this is a really extensive heat wave, and the part in West Asia, World Weather Attribution said was 5 times more likely to happen, to be that as that intense because of global warming. It extended into Gaza, where the extreme heat worsened the living conditions for 1.7 million displaced people, which is particularly terrible. And then we get, as a result of those higher temperatures, we get drier droughts and worsening wildfires. Because as you have higher temperatures, that increases the evaporation in the soil and the vegetation. And so in areas that are prone to drought, that already tend to be dry, then the high temperatures just create more dryness in the soils and the vegetation. So droughts get drier, and then as the vegetation dries out, also that creates more wildfire fuel because now you have more kind of dry material to burn in a wildfire. So that's particularly a problem in places like California and the Amazon. Here I'm in California. We've had kind of a periodic like times with really bad wildfire seasons, especially between like 2017 and 2021. We had a bunch of record wildfire seasons. 2022 and 2023, we got lucky. We had some wet weather, and so those were mild wildfire seasons. This year, we're back to having a pretty bad wildfire season. It's probably going to be at least top 10. It's not the worst, but it's pretty bad again. But the Amazon is having a really bad drought and wildfire season. So World Weather Attribution looked at that, what's happening in the Amazon. There's also been some other research, but basically they found that the drought that's happening in the Amazon right now, which is a pretty intense drought, World Weather Attribution said that climate change increased the likelihood of that intense drought by about 10 to 30 times. That drought is also contributing to wildfires, pretty bad wildfires in the Amazon this year. And World Weather Attribution said that those wildfires became about 40% more damaging and 4 to 5 times more likely to happen as a result of climate change. In general, the Amazon is seeing 3 times more days with hot and dry extreme wildfire conditions. There was another study looking specifically at those dry wildfire conditions in the Amazon. And a separate study published not too long ago estimated that by 2050, between 10% and 47% of the Amazon is going to be exposed to sufficient stress from these droughts and wildfires to trigger a tipping point collapse, which basically means that the tree dense Amazon has a lot less trees, potentially very few trees, and transitions to like a savanna, which is mostly grass and stuff and shrubs and a few trees, depending on just how bad that collapse is. But there's a large range there, 10 to 47%. Could be just a little bad, could be very bad. There's a lot of uncertainty there. So just illustrates how much damage these droughts and wildfires are doing, though, because the Amazon is a really important carbon sink. It stores a lot of our carbon that we don't want to release back into the atmosphere. And then the 2 big islands off of Italy, Sicily and Sardinia, are also experiencing really bad droughts this year that World Weather Attribution looked at. They've been having extreme drought conditions since May. And in fact, they've been rationing water since February, and their reservoirs are almost dry. So it's been a really bad drought situation there. And World Weather Attribution concluded that it's so hot and so dry there that those conditions would have been almost impossible without the presence of climate change. It just wouldn't have been that bad. And they didn't quantify, but they said similar conditions are going to become more frequent and more intense in these regions in a warmer world. So then our last category, we're going to talk about storms and precipitation and flooding. We're going to do a little science history and talk about Nicolas Leonard Sadi-Carnot, who was this French military engineer and physicist. And 200 years ago, he discovered this relationship between temperature and vapor pressure that scientists subsequently used to estimate that for every 1 degree Celsius of global warming, the atmosphere holds 7% more water vapor. So this is kind of the key relationship for determining how much more precipitation we get in a warmer world. And as you have more water vapor in the atmosphere and a storm goes through, then it kind of just has more water available to drop as precipitation. And so you get more often you get extreme precipitation, and then more often it's more likely to flood. And so basically you can sum it up saying when it rains, it is more likely to pour. We had a big extreme precipitation flooding event in Central Europe, kind of around the Austria area in September, just last month. It was Central Europe's, by far, its most intense rainfall recorded in that region, and it directly affected nearly 2 million people. Lots of flooding associated with that. So World Weather Attribution looked at that event. They said conservatively, climate change made those floods twice as likely and 7% more intense. So there's kind of that 7% that we tend to see as a result of warming, increasing the water vapor in the atmosphere. And so they said if we get from today, we're at like 1.3 degrees Celsius global warming. If we get up to 2 degrees Celsius, then we'll get to about 5% more intensity because of, again, more water vapor in the atmosphere. You get 5% more intense, similar storms at that point in the future. And these kinds of floods will become 50% more likely to happen. And in July, in northern Kerala, India, there was this extreme monsoon downpour that triggered massive landslides and killed hundreds of people as a result. It was that region's 3rd heaviest one-day rainfall event on record. And so World Weather Attribution looked at that one, and they said global warming increased the intensity of that precipitation by something like 10%. Again, pretty consistent with the amount of water vapor increase in the atmosphere. And they said, okay, if we go from the 1.3 degrees of global warming today to the 2 degrees in the future, then similar events will become an additional 4% more intense. So very similar to what they concluded with the Central Europe flooding in the future. And then in southern Brazil, there's this state called Rio Grande do Sul, and it also had some really bad flooding in late April to early May. They got 16 inches of rain in about a week or two there. And more than 90% of that state was affected by flooding, just tons of flooding as a result. Displaced over 500,000 people, 150,000 were injured, and 169 fatalities associated with this intense rainfall and flooding in southern Brazil. And so World Weather Attribution looked at this one. Very similar conclusions as the other two. They said climate change made it twice as likely to happen and 6 to 9% more intense than it would otherwise have been in the absence of global warming. And similarly, if we get to 2 degrees Celsius warming, then similar events will be twice as likely to happen and 4% more intense than they are today. So that's kind of all the bad, the grim news, the attribution of all the nasty weather this year. And so I like to stop, conclude with the question, what can we do about it? Because we obviously want to do something about it. And one thing that I think a lot of people don't realize is that once we get to net zero emissions, then global warming stops. And this is kind of a misperception because there is what's known as warming in the pipeline due to greenhouse gases we've already put in the atmosphere. And so people think, well, once we stop putting greenhouse gases in the atmosphere, then that warming in the pipeline will still happen, which is resulting from heat sloshing around between the oceans and air. So that's kind of what you see if you look at this chart on the right here. We're looking at a climate model simulation of what happens in a couple of different scenarios. This red one is if you keep the concentrations of greenhouse gases in the atmosphere constant. So like, for example, right now we're at like 420 parts per million of carbon dioxide in the atmosphere. So if you just keep it there and don't increase it, then you can see that warming in the pipeline still happens. Temperatures do go up because of the heat that's still kind of sloshing around and not in an equilibrium yet. But if we go to zero emissions, a second thing happens, which is that the natural carbon cycle actually pulls carbon out of the atmosphere. And so that reduction in carbon in the atmosphere and the amount of greenhouse gases in the atmosphere actually offsets the warming in the pipeline pretty much equal, like it has an equal cooling effect. And so you can see that's that blue line, it pretty much flattens out. So that's the good news, is that if we can get to net zero emissions, then global warming stops. And if global warming stops, then these climate impacts stop getting worse. And so that's kind of at least our first goal, is to get to net zero emissions to stop these extreme weather events from getting worse. And then in the long term, we can like pull more carbon out of the atmosphere, get to like net negative emissions, reduce the amount of greenhouse gases in the atmosphere, reduce the temperatures, and then we can actually lessen these extreme weather events, make them less extreme over time. But first, we got to get to net zero, and then we'll get to net negative emissions and start to reverse the problem. So that's the good news. But we got to get there first. And so what we're going to do, we got to pass some climate policies to get to net zero. Our goal in the United States is to get to net zero emissions by 2050. A bunch of countries have very similar goals. And so that's, of course, what we're trying to do at CCL, is pass those policies like carbon pricing and permitting reform and forest legislation and whatnot to get there. In the meantime, we're not going to get to net zero until, in the US 2050, globally, probably more like 2075, maybe. So it's still, things are going to get worse for a while. And so it's important to try to be prepared, try to adapt to your conditions, know what your local extreme weather events are. If you're in a hurricane impact zone, if you're in a wildfire zone, if you're, prone to droughts, floods, whatnot, just know what your risks are and be prepared in the case of an emergency, because they're becoming more frequent and they're becoming more intense. So for example, have a kit ready if you're in a hurricane zone, know where your escape routes are, and just be prepared, listen to warnings, pay attention to warnings, and just try to be prepared as prepared as you can be.
Oh, you can also log your attendance by going through the action tracker and logging it that way.
And that's it.
And here's Dana's email and Rick's email and a link to the Nerd Corner, which has by far the most active forum on community. And I encourage you to post questions there, because Dana loves answering tons of questions, a dozen questions a day probably in the Nerd Corner.
Thank you for listening to this episode of Citizens Climate Lobby's training program. You can tune into more episodes anywhere podcasts are available. Inspired by what you heard today? Join Citizens Climate Lobby to advocate for bipartisan climate solutions. Go to community.citizensclimate.org to find more trainings, resources, your local chapter, national action teams, discussion forums, and more. Be sure to like our Facebook page and follow us on Twitter and Instagram @CitizensClimate. We also invite all of our listeners to subscribe to our YouTube channel for more inspiration.
Like what you hear? Recommend us to your friends and make sure to give us a 5-star rating. It helps us show up on other listeners' feeds. Feel free to pass on any suggestions for future episodes in the comments as well.
And together, we are creating the political will for a livable world.